I'm going to do a bit of a different take to the first three presentations. I'm from Hess. My name is Sten Tham. I live up in North Dakota. And what we're going to talk to you today is more of just a general case study of how we took the OT, IT convergence, and how we used that system and that digital transformation to try and manage our people better and our processes better. So it's really just one large big case study. If you have any questions on the technical aspect of how we did this, I can go to the Mobilio stand afterwards. We can have a conversation about that. I'm not going to talk too much about that, honestly. It's just about a case study. So hopefully you enjoy it. If you do have any questions, definitely let me know. Okay, that's some stuff. So this is where we're at. This is Hess, North Dakota. We are in the unconventionals business, so it's 550,000 net acres, big place. It's basically, the takeaway here is it's the size of New England. Massive, massive place spread out along a large surface area. And the key thing here is that there's a lot of activity going on. So you can see that we've basically got in the region of 1,600 wells, sort of 800 facilities, and connected devices, as you can see, just a huge amount of those. So radio towers, Wi-Fi antennas, and 40,000 connected pieces of equipment, of which any one of those you can have up to 10 individual data points, right? The key thing here is that what used to happen in the old days, before we had the digital transformation journey, was that you actually had to go and find all this equipment yourself. You used to have to go and send a person out there, right? So if I have an issue with a particular device or something isn't working properly, I have to go and send a human out to go and figure out what's going on. So that hopefully gives you a bit of a context as to why we started this journey at all. So what we set up was this journey, what we call exception-based surveillance, and we try and think about this idea of exception-based surveillance or this digital transformation in four ways. We basically say, well, the key premise here is how do we flip the paradigm of people going to find out what's wrong, and instead say, how does the equipment tell us what's wrong, right? So a lot of the stuff that you have heard over the last couple of days is based off of that premise. So how do I use data to basically tell me which equipment is or isn't working properly? And that's what we call that's the first quadrant. It's that intelligent work piece. The second piece is it's about the person. So when you have one of these systems tell you, hey, go do something, we don't really often talk about, well, what happens next, right? What do you do with that person? How do you get that person the right information to go and solve that issue? So we basically define that next part as basically saying we want to understand what is the kind of standard work that any individual involved in solving that particular issue is going to undertake to solve it. And that's the second quadrant. The third one is this idea of what we call value stream management. And that is essentially a digital representation of your end-to-end value stream. It says, I want to know at any given time who's doing what, when, with what materials, what information, and what does it look like from the very beginning when this digital system told me something wasn't working, all the way through to I have someone going to go and spend money to go and fix it. I want to see that entire end-to-end value stream in a digital process. And then the fourth one, is this idea that when I have that visualization and I have that digital transformation mapped, I can then use that information to continue to improve my processes and continue to improve my people and my business in general. So that's really what this whole idea was about. To give you an idea of what the business challenge was, if any of you guys own oil and gas stock, you'll know it's been a rocky ride over the last couple of years. And we have that pressure basically every day. So you've got this demand to say increase production, decrease operating costs. You're on a wild ride when it comes to what your oil price is. Oh, and by the way, we're going to add more of this stuff, and given all the demands that we're going to give you, the number of people you're going to get isn't going to match the number of equipment you're going to get. So get creative here. And how do you do that, right? So that was the business premise, and really this idea that we had was this idea of digital transformation, this exception-based surveillance idea, was a way that we could lean out our business to try and meet this demand. So what does that really look like? So again, what we try and do, and here's an example, we basically you have at any given process, you can say, I have diagnostics that tell me when something's working correctly or not, right? Depending on what that looks like, I can have surface issues, artificial lift issues, wellbore issues. Any of those things could be causing an issue, depending on what type of analysis I'm doing. And then when I determine what the kind of issue is, I then have to go and plan, schedule, get the materials, perform the rig work, and eventually bring, say, a well back online. And that entire end-to-end process, there's a lot of information transfer going on. Yeah, there's a lot of work material and information flow between those various parts of the organization that has to get that one thing that was broken all the way through to getting fixed. And so the premise here is, how do I connect my people in a digital way to make sure that that whole process is working very seamlessly? And that for us was part of our big digital transformation journey. So the way we did this was we essentially came up with a mobile solution which offers a lot of different things. And this one we use as Mobidio. Basically what it does is it allows us to, once a process upset has been initiated or found, we can basically dispatch that person in a digital way the information they need to say, hey, there's an issue on facility X at point Y, can you go and fix it, please? And what we do is we then say, okay, well, when that person gets to that particular point, we give them a very detailed instructions about how they're supposed to facilitate that troubleshooting and what they do when they find the issue. Equally, what the software also allows us to do is it allows us to connect the managers directly to what the people are doing. So as a manager of people, you can see exactly how much any one individual is doing, how long it's taking them, what kind of information they're capturing or not capturing, and basically manage your systems more effectively that way. And then all in all, when you have those pieces of information, you can of course allow this platform of digital transformation that says I can operate in a more excellent way because I have so much information. I can use my engineering functions to try and use that information to get better, so on and so forth. So this next slide is, come on, work. There we go. So for us, again, this is just a very high level stuff, but we basically take master transactional data, we link that up, we process information documentation and SCADA data, and we basically facilitate that all the way through to either one of those two platforms, either the connected manager or the connected worker, to basically facilitate that workflow. And here's some of the screens of stuff that we do. So you can see an example. That's an example of what a connected worker might look at. They can see PNIDs, they can see data capture, they can ask particular timestamps, GPS locations, that kind of thing. And then from the managerial side, of course, you have a plethora of data that you can then use to improve your processes. So I'm going to kind of spend hopefully a little bit more time giving you 3 case studies that we did here, and hopefully this will give you guys some food for thought. You can ask any questions that you have. So this is what's happened. So as of last year, we basically processed 86,000 exceptions across 28 value streams. And so basically what we mean by a value stream is we say, for example, hey, one well has gone down, it needs subsurface work and a rig to go and fix it. That might be one value stream. Another one might be, hey, we have a treated temperature upset that requires surface corrective work. That might be another value stream. We have stuff in the regulatory space that says, I haven't had a valid well test in this space. The Industrial Commission in North Dakota wants to know why I haven't got that test. So can you please give me that information? So there's a wide gambit of what different types of value streams we look at. But we basically have 28 of these, and they cover 15 different business functions. So you're talking about engineering groups, frontline responders, regulatory analysts, technical analysts, everybody, all involved with the same type of system to basically visualize where your work is and how long it's taking you. So what you have here is actually a digital representation of our subsurface value stream. And what you can see, this is just a straight screenshot of a Spotfire report that we plonk onto the data that we gather. And by doing that, we can essentially see at any given stage in the process, whether it's the first initiation that says, hey, I would like you, person, to go and figure out why that particular issue is broken. In this case, a well has gone down. You can basically click on it, and at any given time, so you can see over there in the corner, it says 102 of those are happening basically right now. And I can go as a manager and say, well, that's interesting. Is that normal? Is 102 something that my resources are capable of delivering or not? And if they aren't, can I reallocate my resources to try and meet that demand? Equally, as you go through this entire end-to-end system, what we do is we actually try and analyze how long it's taking each group to do particular work, and we look for outliers. So if you have a distribution that says this particular task should take 2 days, and I suddenly see a flare-up, and I say, well, that's now taking 4 days, I need, as a manager of those people, to go and understand why. It could be that we have data loss, it could be a confusion of what it is that I'm asking you to do, or there can be an improvement opportunity that they found that they're trying to problem solve, for example. But the end-to-end thing here is that from a management perspective, it becomes very clear about where your work is, and it allows you the opportunity to manage your people in a more effective way because you have a digital representation of exactly what's going on in your value stream. Okay, so that's really what that looks like. Here's another example. This is a specific value stream. We call this the production rate value stream. The way this value stream works is we have an analysis on our decline curve. So we essentially have a production profile forecast. And based off of that forecast to the actual production that we're receiving, if it goes out of a certain tolerance, we initiate some work. And we say, hey, something's not right here. Person A, please go and start evaluating on-site why you think that might be true. And what happens is, as you go through that process, they will basically escalate what we call an escalation. So to give you a very poor analogy, it's kind of like hitting your head if you fall outside on some ice and you I'm from North Dakota, so we do that quite sometimes. But if you hit your head on the ice, you might get an EMT come up and just say, hey, you're okay. You just take some Tylenol, and it's just a light bump. Don't worry about it. You're fixed. Okay. If that isn't true, they might say, well, actually, you might need to go to the hospital. This looks quite serious. You've got some abrasions and stuff. You might want to go to the hospital and get checked in. So you've kind of escalated that problem, right? The first responder has said, no, Tylenol's not going to cut it this time. You're going to have to go and do something more. Okay, so then you go to the hospital, and then maybe you get just a general specialist, and they say, you know what, I'm not so sure about this. Do you want to go and see a brain surgeon? Maybe you've got something really wrong here based on the CT scans we've done, and you have to go to a specialist to get some proper treatment. So as you have this triage of escalation for any given problem, you have to have different parts of the business that resolve that issue. And the same thing goes on here. So for us, in this particular space, we have about 4,000 of these last year. The interesting thing is on the analytics is depending on the person who's fixing the issue, you get a different response or a different uplift to the production profile that you want. What we found is that the earlier on in the process, you get smaller gains. The later on in the process, so we're talking like the brain surgeons, you get bigger gains. And so we have this distribution pattern which shows that as we escalate the issues further up in the business, we get more returns off of it. But the interesting question then is why? Why do we have that? Does that make sense? So once you start to visualize your process and you understand what the data is telling you, you can then manipulate how your business works to say, well, I want to actually maybe change the way this work is even being initiated. Am I initiating at the right level? Right? Do I even need to go to that first responder? Can I just go straight to the brain surgeon? Can I do some data analytics on this information or make a smarter signal that just says go straight there? Those are the kind of things that once you have this end-to-end process, you can start your engineers thinking about. So some quick stuff. By visualizing this end-to-end process, again, we get about 5 barrels of oil equivalent per day per signal. I'm not allowed to put up the math, but you guys can do some mental math if you want about how much value that is to the corporation. The other interesting thing is that just by visualizing this digital process, we've been able to cut the processing time from our engineering space by about 35%, and I would say that's probably even conservative. In certain areas, we've seen as much as 50%, just by being able to see your end-to-end process. So here's another one that we do. We analyze the amount of belt slippage on our pumping units. When you have belt slippage on your pumping units, what it means is that the drive isn't meeting basically the artificial lift system. You get an efficiency loss, and it can lead to catastrophic damage, in which case the belts break and your pumping unit sits down for a couple of days. You have to go and fix it. So for us, what we did is we said, well, this is a big issue for us. We want to try and put some data analytics on it, and we want to say, every time this belt slip starts happening, we want to go and send out an operator to go and have a look. So in this particular case, you can see that from the graph at the top there, we were able to reduce the number of signals that were generated by about 90% when this first started. And the other really interesting thing about this, and sorry, this is a really bad picture, but I don't know if you can see this here. So once we had end-to-end visualization of how this process was working, what we began to see in the people was some interesting behaviors. So in this particular case, this is one of our worst acting wells. And what you can see here is every time there's this light color, what it means is that the digital system told somebody, hey, Bob, can you go out to well X and go and figure out if this thing's working okay? And what Bob has gone and done is he's gone up to the location. He said, yeah, it's great. I'm going to close this. I think it's fine. Okay, well, hey, Bob, it came, oh, sorry, wrong button. I've done something wrong here. Hang on a minute. I have no idea. Let me skip through here. Bingo, thank you. So what Bob's then done is he's gone back the next day. So this is about a sort of a 2-day, 3-day period, and the signals come back again. And he's gone out there again, and he said, well, it looks fine. I'm going to close it. So this keeps going on and on and on and on and on. And eventually what we found was that when you actually take care of this system, you actually trust the process, when it actually goes through to the engineering functions and says, actually we can go and tighten these belts or do some corrective action, we're going to spend some money on this, what happens is it completely stops. So in this particular case, that person basically closed the signal sort of, 12, 15 times before eventually saying, hang on a minute, I'm going to elevate this problem to an engineering function, and we're going to go and spend some money on it. As soon as that happened, no more issue, right? Belts are running properly, no more big problems. And as a result of that, we've basically seen a 30% improvement in the success rate just by visualizing what the people are doing. The last one I'll say is so for us in North Dakota, one of our big issues that we have downhole is that we have these holes in our tubing. And when you have that, you basically spend a lot of energy trying to get the production to surface, but it just comes, it recircles. You can't actually get it into the tanks. So what we did here was we actually did a full analytics model, statistical machine learning. And what we were able to do by basically analyzing certain input parameters, we were able to almost predict within about 3 days early of when one of these things was going to happen. And by doing that, you basically say, well, I'm going to start the entire process 3 days early. So in this particular case, we have about 360 of these signals every year, and every single one of these, and this is conservative, of course, is that you're saying that I'm going to basically get this information 3 days early. And on average, if each well produces about 100 barrels of oil equivalent a day, you're looking at around 220 barrel of oil equivalent every single one of the time you do that. So again, I'm not going to do the mental math for you, but if you do it for yourself, you can see value to the corporation comes pretty quickly when you look at that. So anyway, hopefully that was a good example of what we're doing with the digital transformation journey and a couple of case studies. Again, if you guys have any questions, happy to hear them.